And you've done a lot to sort of try to bring the Python ecosystem to an area where those type of memory errors aren't as possible. Can you maybe talk a little bit about that, or help some of our less technical listeners understand what memory overflows and memory safety is?
Absolutely. So for probably more than 10 years now, I've been very concerned about a category of security vulnerabilities that are like we call memory unsafety. And these are kind of a family of vulnerabilities that all at their root have to do with how programs manage memory, and specifically how some programming languages kind of make it very easy to make a set of mistakes. The most common of these is a thing called a buffer overflow, which is basically like imagine you have a list of 10 items, like what should happen if you ask for the 11th item? And like the answer is clearly like some sort of error, 11th item doesn't exist, something like that. And in programming languages that are memory unsafe, what happens is instead the computer goes, oh, if I pretend this list is 11 items, I'll just give you the item that's where the 11th item would be in memory. And like it turns out that's somebody else's data. That you're right, like you just this is like not what you ever want. But for kind of historic reasons that like particularly older computers were slower and it was kind of thought to be very expensive to always check, do I really have a space for 11 items? Early programming languages did not automatically check for you, like does an 11th item exist? So that's kind of one of the big sources of memory and safety.